Let's see.
I have to say, I felt like such a Zoom pro over this summer because I've been using Zoom for so long, and all my coworkers were like, "What the heck is Zoom?
Yeah.
It work?"
I've
It's like,
I've done most of my book tour was virtual this summer.
We're
So yeah, it was
live,
all
by the
on
way,
Zoom. Yeah.
in theory.
Oh,
Um,
yay.
just in case you weren't aware.
hey,
I actually
folks.
found my life has gotten a lot easier. I haven't needed to use my little sign in a long time.
Need to join
Yeah.
yeah.
So
That's
I
funny,
every now and then I do, but yeah, I know from that perspective. I mean, people are now trained on Zoom,
right?
and
Yes.
are stuck at home. So it's a target rich
It's
environment. I've been able
it's
to just
it's
book.
funny. It's funny to see people go through all the same learning curve we've done years ago with Zoom
Yeah.
and Google Hangouts and everything
Yeah,
Yeah,
else.
when we
yeah,
stopped using
yeah,
Google Hangouts and switched to Zoom like a couple of years ago, we were like,
Yeah.
"What the heck?
yeah,
What's all this going on?
yeah, yeah,
I don't
yeah. No, it's funny.
understand."
Everybody. I feel like I could have just gone and just made the rounds, going, "Let me help you. Let me help you." And
Yeah.
in fact,
Yeah.
all these people
You could have made a lot of
who
money
are
off of that, I'm sure.
yeah, and so many people are like on book tours now. They're on virtual book tours,
Yep.
Yeah.
and I'm making recommendations about how to improve their setup. You know, get a better microphone, get better lighting.
Yeah.
It's not like it's expensive, and you can make yourself a much easier, a much better sort of participant for whatever you're trying to be a part of.
Yeah,
Yeah.
it's been really interesting. I joined the podcast team at AGU. And like they've had to, usually they do like all their interviews, in person, they'll go travel wherever, but obviously we can't do that. And so it's all like, how do you set up a good audio situation at home with Zoom and
Yeah.
all of that? And I was like, aha, I know how that works already.
Exactly.
That's a bad idea. Don't do that, team.
That's it.
That's awesome.
That is the purpose
Where,
of
yeah,
the entire weekly space hangout is to just
Yeah.
yes.
get people
Zoom teachers.
Zoom teachers. Yeah, exactly.
Right.
Neil, you were saying, Moira, I saw your interview with Dr. Brian Keating. You have a cool story. I didn't know you did an interview with Brian Keating. That's awesome.
Yeah, it came out last week or the week before. It was
Awesome.
fun.
Yeah.
What did you guys talk about?
Oh, very cool.
Me?
You didn't talk about him losing the Nobel Prize? That didn't come up?
No, but there was a poster
Casual
for it,
conversation.
for the book in the background behind him.
Yeah.
Very cool.
But it's great. Actually, he's killing it. He's doing a great job. He's got, he knows everybody in the industry, and he's been doing a really great
Yeah.
podcast. So if you haven't checked it out, definitely check out Dr. Brian Keating. I'm sure I'll do another interview with him at some point. But yeah, he's a riot. Yeah, I'm mirrored.
Nice.
That's right. People are asking me why I'm mirrored, why my sign is backwards.
Oh, that's right. You are.
Yeah. So when I'm in this mode, it's my secondary camera, and then when I'm in this mode, then everything is normal.
You looked the same to me.
Yeah.
Both
You guys don't.
times?
You
Like-
guys don't see the difference.
I don't see the
Yeah.
broadcast
It's
version.
Yeah,
like
you-
using the selfie cam.
You
on the
guys
phone,
have
yeah.
no idea what I'm doing as I'm actually
I don't.
engineering the show. You just see whoever's on the screen, but the audience sees the larger, more
Yeah.
engineered version of the show.
Yeah, though I've seen other people attempt to do what you do, like when you're not here, and it seems way too complicated. Like when other people have to engineer it
Yeah.
live.
Oh, to run it and
Just
host
like-
it. Yeah.
Yeah, to run it and host it and
Yeah.
It's
click all the
much
buttons.
easier to be the
and-
talking head.
Well,
Yeah.
the thing that's
Kind
super
of
funny,
is.
the
I'm
thing
kind
that's
of
actually
good on this
really
end.
easy is when I'm doing, say, Astronomy Cast and I'm just interviewing Pamela, because I
Yeah.
know that I'm about to talk, I can make the transition like that. Because it's not like an engineer has to wait and hear me talking and then try to shift the camera. I know that I'm about to talk, and so it's like I shift the
That
camera
seems
right
like
now.
cheating. Seems like you're cheating, Fraser.
Totally cheating. Yeah, exactly.
Kind of are.
But it's, again, just like anything, it's just like practice. Although my plan is I'm actually going to make it so that the mods can engineer the show. So they can actually put up titles and pictures and all kinds of stuff to enhance the show while we're actually doing the
interesting.
show.
Very cool.
So I'll show you this. Oh, is it
We're just
kicking
We're
around?
gonna ignore my little flyaway hair thing because I haven't gotten a haircut in
Oh,
like
well.
7 months.
We'll show you next week.
I'm not
Nancy and
getting
I
a
have to do
haircut
some
in
practice.
2020, so.
I almost gave in. I
I had my wife trim it a little bit just to get the dead ends out a few weeks ago, but It's like, nope. I have.
Yeah,
I
I
went
don't.
into this-
You guys
I
need
don't
any
trust my
advice?
husband to do that
Anytime.
for me.
This is
Like we have a trimmer, but I don't trust him
Yeah.
to get
Yeah.
near my head.
I went into this needing a haircut in March. I remember that week before we locked down, thinking I should get a haircut this week. So I was like, oh, well,
I actually got a haircut like the week before
Right.
we closed our office, like totally random.
all right. So we should do a show.
We should.
Yeah. So the guest is
I've missed you
pre-recorded.
folks.
So we will go till about the. Let me find out here. Let me find exactly. To the 25-minute away mark. Here's me with my eyes closed. Okay. To about the 25-minute away mark. So we'll go till about the 5:35. So we'll go, and then we'll switch over to the interview with Terry Virts. And it's a long interview, but we had a riot. So highly recommend that you stick around and watch that. Not you guys. You guys are free to go. You get your evening back.
You don't
all
want to
right.
talk to us anymore?
So wait, what's that?
You don't want to talk to us anymore?
If you want to stick around and you guys want to do like some kind of like mystery science theater,
it's
on the-
clear here. I'll probably go out and actually take the scope up to the roof or something.
You know, one of these days we should actually do a mystery science theater, but like on a space show, like a
we
space
did.
movie.
I did.
We should
that
totally
would
do
be
that.
fun.
We did
Like a
Cosmos.
special broadcast thing.
So I did 8 hours. No, the whole however long Cosmos was. I
No, I
booked a
want, like,
different
Interstellar.
guest, a specialist
Gravity.
for each segment of Cosmos, and we updated it for with the modern science as Carl Sagan was talking about it. So he was like, nobody knows
interesting.
what quasars are, and then we
Quasars
talked
are,
about what
yeah.
quasars were. So it was a lot of fun.
Aw.
Interesting.
I
I think I didn't see that.
I don't think I've ever been alive in a time when people didn't know what quasars were.
I remember before we knew there were exoplanets. I remember
I
astronomers
remember that
saying.
too.
Oh.
I remember astronomers saying we may never discover exoplanets.
Okay.
It's just too difficult. So,
I hate to do this, but we gotta do a show. so I'm gonna put you all back in your boxes. Back to me. Here, let me get my
box for 6
intro.
months.
Here we go. All right. Hello and welcome to the Weekly Space Hangout for Wednesday, September 23rd, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about Mars at opposition. Extragalactic planet, question mark? Planet around a white dwarf, exclamation mark? And an ultra-hot Neptune discovered around a sun-like star. So we're going to deal with exoplanets and Mars. Joining me on my screen, I've got Dave Dickinson. David.
hey, still here in Norfolk, still writing, still at work.
Awesome. We've got Dr. Kimberly Cartier. Kimberly.
Hey Fraser, it's been a while.
I know, it's
I'm
been a couple of months.
Still at home for a while.
For a while, still at home. Still
For the
just
foreseeable future. This is
Yeah.
where I am.
This is our life now.
Yep.
Maybe by the end of 2021, a vaccine will roll around. That'd be okay.
I'm no longer putting dates on anything.
Yeah.
Yeah.
That's just not how it's
No,
gonna
I know,
work.
I know. And we've got Moya McTeer. Moya,
Hello, it's good to be back.
you didn't get a doctorate while we were gone, did you?
No, I'm not doctor yet.
No.
Give me like 8 more months. 6
Okay.
more months?
Yeah.
Time
Yeah.
meaningless.
Yeah. I know.
Exciting.
Alex crossed the line, didn't he?
He did,
Yeah.
yeah. Now he's in Taiwan.
Oh, cool.
Yeah, I know.
Doing a
Yes.
postdoc.
Yeah. I know. But I mean, you get that. I think we've been proven to knock at least 6 months off of your doctorate by coming on this show. Worked for Morgan, worked for Kimberly. Yeah, we've so many doctorates. We're a factory of producing doctorates.
Yeah.
Really.
This is where it happens.
This is where it happens right here. It's not all the work. It's not the schools. It's us.
Right.
All right. So before we get into the news this week, I just want to give a huge thank you, as always, to our good friends at the Weekly Space Hangout crew. They are really the executive producers behind the scenes, finding the guests, choosing the stories, organizing everything so that we can show up and bring you this show. So if you want to be a part of this amazing team, go to wshcrew.space and they will give you access to the communication that happens down here in the show, as well as all the behind the scenes stuff, as well as the ability to be an executive producer on the show and help book guests. If you want to talk to an astronaut and say, can we interview you, please? This is how you do it. And they often say yes. So you should totally do it if you want to interview anyone in the space field. All right. Or if you want me to interview anyone in the space field for you, that's how this works. All right. WSHcrew.space. All right. Let's get into the news this week. Moya, you happen to be on my screen. Let's talk about the ultra hot Neptune.
Cool. So I saw this coming up on my news feed and I was like, oh, that's interesting. And then I clicked on it and realized that it's a lot more interesting than I originally thought it was, because this is one of the first objects like this that we've ever found. So about 1 in 200 sun-like stars have ultra short period planets. Those are planets that orbit their star in less than 24 hours. And most of those planets, even though they're a small fraction of all the planets we've found, most of them are rocky or they're Jupiters. So if you've heard the term hot Jupiter, that's what it is. It's a Jupiter that's very close to its star. And we don't see many planets like Neptune orbiting very close to the star, so that there's what we call a hot Neptune desert. And this new discovery that was published earlier this week in Nature Astronomy is talking about the hottest hot Neptune yet. It's about 250-ish light years away from us. The planet itself is 29 Earth masses, almost 5 Earth radii, which gives it an average density very similar to Neptune in our solar system. It orbits its star every 19 hours, so it's really, really close to its star, much closer than Mercury, for example, is to our sun. And it has a temperature of about 1,700 degrees Celsius, which is really hot. Other hot Neptunes that we found, the very few that there are, get up to maybe 1,200 degrees Celsius. There's a difference of 500 degrees. This extreme temperature is super exciting because at that temperature, molecules can actually break down into their constituent elements, and metals can become ionized. So we get more interesting chemistry in these environments than you can see in other places. And that basically just gives astrochemists and other researchers a new exciting laboratory to do observational experiments in.
I'm sort of imagining I guess because things are being boiled, that chemicals are able to then move around into the atmosphere in ways that we wouldn't normally expect. Normally they'd be sequestered at different layers that you really can't reach. But in this case, because you've got almost maybe even convection cells in the atmosphere that's pulling stuff up to the top, then you might have a hint of what might be in a Neptune just in general. And now you've got one that's on fire that you can see. Is that sort of what's going on here?
Maybe. There are plans to study this planet further, to use transmission spectroscopy, so looking at the light coming from its sun, from its star, passing through the atmosphere to figure out what elements and molecules might exist in the atmosphere. So more research has to be done. But go ahead.
No, go ahead. Yeah.
Another weird thing about this planet is that it still has an atmosphere, like a pretty thick atmosphere, about 10% of its mass, which is a lot bigger than you would expect for a planet so close to its star, because radiation from the star should blow away most of the atmosphere. So
Right. That's what I was going to ask. Yeah, the radiation is going to be blasting that planet.
Exactly. So one hypothesis is that maybe this planet started off much more massive and closer to its star. So it was a hot Jupiter, but then the radiation from the star blew away this big, puffy Jupiter-like atmosphere, leaving the inner Neptune core. And then because it lost its mass, it also migrated away from the star to a cooler, safer place. And now it's able to hold on to its atmosphere better.
And Moya, we just wanted to ask real quick, what telescope or observatory discovered this?
Yeah, great question. It was discovered with TESS, so it's a TESS object. And then they did ground-based follow-ups to get more photometry data and some spectroscopy data, but not great, so they have to do follow-ups.
Wow, it seems kind of far out for TESS, but that's kind of cool.
Yeah.
And I guess, with the hot Jupiters, one of the big mysteries was how a planet could actually get that close to its star and remain in a stable orbit. Does it make more or less sense for a hot Neptune with less mass to be able to remain stable in an orbit around a star like this?
Oh, that's a great question. I think it depends so much on what the architecture of the whole system is. What other
Right.
planets are there? One
Pushing
of
and
the
pulling on it.
Yeah, because I think we're still trying to figure out exactly what makes hot Jupiters migrate in and out of the solar system, or like closer in and closer and further out. And it really does depend on what types of planets you have around you and how your orbits are in resonance with them.
Right. Yeah, people always ask me, like, what would happen if if you had, like, if someone removed, say, Jupiter or other planets from the solar system, like, would that cause chaos? But it would be like the opposite. It would cause less chaos. It would make everything smooth out. Like, Jupiter is the bully that's pushing everything around. And so if you got some large planet that was orbiting around it as well, it could be perturbing its orbit. And in fact, that's possibly how these planets get that close in the first place, is that there is these evolution of the entire solar system over time.
Yeah, over billions of years.
Now, is there any kind of like limit? Like, a lot of the times when something is discovered like it's for the first time, it's because it's at the very limits of what we are able to detect. Is this at the limit of what we're able to detect, or could we go smaller? Could we find hot super Earths, ultra hot super Earths?
Yeah, we can, and we have. We found more rocky, short period planets and ultra short period planets than we have found Neptunes. But just in general, I don't know if it's a limit thing or if it's fundamental to the distribution of planetary characteristics. But there is a Neptune desert, like most planets.
Right,
that
I
we
did
find
hear about
smaller.
that. Yeah, that there is a Neptune desert.
Yeah, so there's that already, but I don't know why they would be harder to find.
Right.
Because if we can already find Earths.
I know for transiting usually picks up the planets that are closer because they're more likely to transit in the first place from our line of sight. We're not going to see the ones far out, like, because it's more likely they won't transit.
But we are so far a lot more likely to find these smaller planets around, say, M dwarfs, as opposed to the larger sun-like stars. So this is exciting that it's a sun-like star and not a smaller star.
Yeah.
But go
and
Tess.
I think, go Tess. A lot of times I hear people wondering, like, why is it so exciting when we find the first blah type of planet? And reading this article was the first time I thought I saw a good answer to that. So this new type of planet, an ultra hot short period Neptune around a sun-like star, is really exciting because it expands our ideas of what types of systems and processes can be possible.
Yeah.
Because before this, people thought that radiation from stars should be too strong and should just eliminate atmospheres around planets that close to the star. But now we know that that's not necessarily the case. And so we can start thinking about what cool new processes might make that possible. And that's what drives science.
Got a fascinating question from Neil Yu. Do the swirling molten metal planets have wild magnetic fields? Do you think that it would have any impact on the magnetic field of a planet?
I think so. I mean, that's why Jupiter's magnetic field is so big. It has metallic hydrogen.
But in the center. And so if you've got more metal moving around in the atmosphere of the planet, I wonder if that would have an impact as well. Because you wouldn't necessarily have the same level of magnetic field from metallic hydrogen in a Neptune mass planet. But maybe, anyway, it's an interesting idea.
Yeah.
You know, Fraser, that EV scope we were talking about, people are doing exoplanet light curves.
Really?
With that scope, yes.
Oh, that's amazing.
It's like that to me is incredible that you can actually detect an exoplanet with a backyard telescope.
Yeah.
Like, how cool is that?
Yeah. No, I know that a lot of people are able to are able to confirm exoplanets. A lot of amateurs are starting to confirm exoplanets now using backyard telescopes. But I didn't know you could do it with an EV scope. That's incredible. That's really amazing.
So now you need the first exoplanet discovered by an amateur. That would be a cool
That's
story.
been
Did Planet Hunters not count?
Yeah, no, that
that's true. Online.
Yeah, no.
I mean, the data come from Kepler, but
find an exoplanet just a couple of months ago for the
Oh,
first
okay.
time. Yeah. We reported it. I don't remember who did the story, but actually there's a YouTube channel, Exoplanets channel, and he's actually managing the team that discovered the exoplanets. It's like a team of citizen scientists that observed a bunch of stars and were able to find the planets together.
Interesting. That's too cool.
Yeah. I think it's just inevitable at this point. Just as better cameras are made available to regular people and you can collaborate on the internet, this kind of thing's going to happen more and more often. Well, thanks, Moya. Dave, you're on my screen. Let's talk about Mars at opposition.
Yeah, 2020 is a Mars year, and Mars comes up at opposition right on October 13th. So it's coming up. I just wrote about it for Universe today, and this is really the best time right around opposition season when the sun is. We say opposition because what it is Mars is rising opposite as the sun is setting, and it's at its closest point to Earth. So unlike a lot of planets, there's only a window of a few months where Mars is really good to observe when it's that close, right around opposition. And this comes around about once every 26 months. So 2018, all the even years right now are Mars years, 2018, 2020, 2022. But there's another thing about this opposition that's kind of special because Mars it just passed perihelion in August. So we've had a good cycle. Everybody might remember the 2003 opposition.
That was when Mars was as big as the moon, right?
Yeah, that's when the email meme started. That just won't die. That
Did you know,
it's funny. I found
another thing that you weren't around for, Moya. Oh my God!
Yeah. It still comes around.
It still comes around. Yeah.
I see it all the time.
It's funny in 20.
I think Moya might. Are you you're looking confused? Have you not gotten these emails? Have you not seen this thing? Oh man!
No.
Oh,
Back
Dave, can you just explain the Mars as big as the moon before we move on?
Yes, it came around as a chain email back pre-social media in 2003 during the opposition to Mars because that was historic, and Mars was really close. But somehow it got out there, and you'll have people in your family or friends will say, "Hey, I hear that Mars is going to appear as big as the moon," and you're like, "That's not even wrong. I can't even explain. How can I break?"
So do you know how that happened? That what happened was an observatory or a planetarium put out an email that said that in a telescope, in a small telescope with an 80 times magnification, you will see Mars as big as the moon would look with your unaided eye.
Which is space.
And somebody just hacked out.
And then you truncate it and put it in a headline.
Yeah, put it in a headline. Mars as big as the moon. Yeah.
It's funny, when you asked me to write about this in 2016, I actually went through and found every Universe Today because we write about it every time it comes around. And there was a chain of Universe Today articles from 2016 all the way back to 2003. Yes. Every August there was an article.
Yeah, because we get the emails every year. People are like, "I've heard this is going to happen." In fact, we got it this year, and I just don't have the cart to just do it again. I'm just like, I don't care anymore.
I know. It's kind of like, I have to write about this again. Just pick one of your old
stories and say, "Here, read this."
I know. It's just like copy paste, and then
So when is the perfect Mars? When's the best day to go out and look at Mars?
I'd say any clear night over the next few months. A cool day on October 3rd, the moon is actually going to occult Mars. You might notice it's in a cycle of every time the moon occult, meaning it's going to pass in front of Mars. And this happened last lunation. We had some really cool pictures of Mars and the moon near each other. And on October 3rd, for South America, they're going to see an occultation. But here in North America, they're going to be very, very close. So an interesting thing to do, and I did this last time it passed last month, is Mars, when it's this bright, about -2, I believe, you can actually see it in the daytime if you know exactly where to look for it. And the moon does help. It's an unusual observation, but after sunrise, during that last occultation, I stood up on the roof here and I looked and I followed Mars up into the daytime near the moon. You could still see it, so that's kind of interesting.
I've done that with Venus, but I've never tried with Mars or.
It only works
Jupiter.
Near opposition.
Yeah,
Jupiter's not too bad. Sometimes I've aimed a telescope and kept tracking it up into the daytime and shown people. But this is the oppositions are getting successively worse now every 2 years because Mars is going to be moving toward where it's at aphelion instead of perihelion. Mars has a pretty eccentric orbit.
Yeah.
So this is going to be the best opposition. It's going to be 22 arc seconds across around October 6th. And the biggest it can get is 25 arc seconds. So that's pretty respectable.
Yeah.
2035 is the next time we're going to break that again. So for this decade, for actually the next decade and a half, this is the best time.
And even in a small telescope, you're seeing the poles, you're seeing some darker features on the surface.
The first thing visually that always pops out to me, and I sketch it sometimes too. I have a new imaging camera, so sometimes I'm imaging, sometimes I'm sketching, sometimes I'm just looking. The pole caps always pop out. The southern hemisphere on this pass is tipped forward to us because Mars just passed winter solstice this month. So, but actually, you can. And what's interesting I always notice if you look at Mars the same evening with the telescope at the same time, its day is only 24 or 37 minutes longer than ours. So you're very nearly looking at the same longitude turned forward one night to the next. It only turns just a little bit on each night because we're kind of almost in sync with Mars on our rotation.
They're 24 hours and
37 minutes.
37 minutes, right? Yeah. Okay,
The numbers are still all in my head because I wrote the article this morning. So,
so anything else special that people should be doing as we sort of enjoy this opposition?
A neat thing, I've never done this, I know Bob King has carried it out successfully, is I've never seen the moons of Mars, but during opposition is the best time to try.
Wow.
Phobos and Deimos, they are 11th and 12th magnitude. They wouldn't be hard to see if dazzling negative second magnitude Mars wasn't right nearby.
Yeah, and
so
they orbit pretty
really
close.
Kind of, difficult. They were discovered by Asaph Hall we're talking about the U.S. Naval Observatory. That's actually where they were discovered in 1877 during an opposition.
Yeah.
And the best thing you can do is I've made what they call an occulting bar eyepiece, where you have like maybe a little strip of foil in the field of the eyepiece. You block out Mars and then try to see like either the companion star or the moon next to the planet. So that's I've tried before. I've never seen Phobos or Deimos before, but
I haven't either.
Yeah, they're very difficult, but opposition's the best time to cross them off.
Did you see the occultation of the International Space Station in front of Mars that someone took a picture
I saw that. It was on Astronomy Picture today. I saw that.
Yeah.
And the thing was,
I was just sick.
I had to look and vet it a little bit before I put it out on social media, because remember a few years ago someone did one of Saturn and it came to light that it was a composite. It wasn't actually a transit. So I had to dig a little bit and see what the discussion was in the photo, and I'm like, he put the video out at the same time, so that helped. I looked at it, was like, okay, it's legit, because I saw the actual video of the pass. I've seen a lot of ISS passes.
It's so funny to me when people tell me that, like the space station isn't a real thing. It's just a CGI. Just go outside, look with your eyes, and you can see it head over. Look in binoculars, and you can see that it looks like a little TIE fighter.
It's the same like with the moon missions and stuff. And I tell people, the Apollo launches, they weren't secret launches. Millions of people watch these rockets launch.
Yeah.
I lived in Florida. You can see rocket launches like from Tampa like a couple times a year. So it's these things don't happen, clandestine, like in some secret location. It's everybody. If you live on the Florida Space Coast, you see the rockets actually go up.
Yeah.
Yeah, I think this past week with the whole Venus thing, it has proven that astronomers cannot keep a secret. There's no conspiracy. There's no capacity for conspiracy theory.
Yeah, they couldn't keep 3 hydrogen atoms and a phosphorus atom connected together, found in the cloud tops of Venus, a secret.
Yeah, only like a couple days. They needed to keep it a secret, but nope.
Yeah.
I want to see if there is life, what it's doing to survive all the sulfurous conditions there, because it's still very hostile.
Yeah, yeah.
Let's go diving in our volcanic vents in the ocean. Let's do it.
Well, thanks for the reminder, David. I'm going to definitely go out and try to observe the Mars as often as I can while we have this opposition. You always forget. Mars is always so bright. You forget that it has to go away again. So,
yeah.
Kimberly, tell us about planets.
More planets.
More planets.
Yes. More planets. Yeah, Moya, that's right. Moya set me up really nicely with a planet that we definitely want to get excited about. I have another planet we definitely want to get excited about, and one that we shouldn't get excited about just yet, but to keep our eye on it for later.
All right. Well, why don't you start with that one first so that we can explain why we shouldn't be super excited.
Yeah. Then we'll do the excitement later. Okay. So don't get super excited about this one just yet. I'm putting that out there to start with.
This is boring. Manage your expectations.
It's not boring. It's very exciting. It's just perhaps a little bit premature with the excitement. There was a paper that was published on AstroPH, which is the preprint server for a lot of astronomy papers, claiming the first planet candidate detected in another galaxy. So just as a background, like any exoplanet you ever hear of that we're talking about here, or that you read in the news or anything, all of those planets are all around stars in the Milky Way galaxy, as the only planets that we've officially confirmed to exist. Now, there's no theory that says that planets couldn't form around stars in other galaxies. To the best of our knowledge, stars form the same in every galaxy, and so planets probably form the same in every galaxy too. Not that we know exactly how all the planets form, but it's probably the same mechanism, whatever galaxy you're talking about. The difficulty with detecting a planet in a distant galaxy, many thousands or millions or billions of light years away, it's just that the stars are so faint, and then the planets themselves are going to be even fainter, and you can't really always pick out an individual star in a distant galaxy unless it's doing something like being a supernova or an ultra-luminous X-ray source, which is what this particular paper was talking about, was an ultra-luminous X-ray source in the Whirlpool galaxy, also known as M51.
Yeah.
And in archival data from Chandra and from XMM Newton, I believe, the astronomers noticed a dip in the light coming from this ultraluminous X-ray source. The shape and the depth of this dip in light looks like what a planet would do. But here's why we shouldn't get excited quite yet, because that sounds exciting, and it is.
Yeah.
But don't get excited yet, because it was only one dip in light, and for all other planets that we think we've detected, we generally need 3 dips in light or transits to know that it's really something in orbit around something else,
right,
like a planet. And they only found 1 in the data. The number of photons for each data point that they have is actually very small. That's not terribly surprising given how far away this thing is, and that it's, just one point source in a galaxy. But there's very few photons, which means that their error bars are bigger than what we would like. And the paper is not yet peer reviewed.
Mm-hmm.
So this is not to say that after the peer review process and after some more data, it might be confirmed. It's just not confirmed yet. In my personal opinion, I think it's a little premature to call it a planet candidate. I would call it something like an unknown eclipser or occulter or something like that around an X-ray source. And maybe it is something planet-sized, and maybe it's a planet, but it could also be many other types of objects.
I mean, couldn't a binary star account for that as well? Just, it's going to block the light and it's not going to be as bright enough to see from this distance?
Right. So this object is already in a binary system. The ultraluminous X-ray source, they think, is some sort of massive star plus some sort of stellar remnant, like a neutron star or a black hole, in a binary system, and then whatever the object is occulting that pair of objects.
Right.
The of the options that this thing could be, it could be a planet, something Saturn-ish sized. It could also be a brown dwarf or a white dwarf or an M dwarf or any other number of similar sized objects that don't emit all that much light compared to this X-ray source. It could be lots of things.
An alien megastructure.
We need more data.
Who knows?
Yeah.
Shh.
I don't.
All right. So when you're getting an advance notice, because we kind of found this today on AstroPH, and so the internet, I think, is going to freak out. And so
don't freak out.
So don't freak out. We want you to just be excited, but
if you want,
chill.
Keep it in the back of your mind. Yeah. Put a pin in it.
Planet,
get excited later.
Probably not.
When we have more data and more confirmation.
All right, let's talk about the one to get excited about.
Okay, this one is one to get excited about This one is a giant planet that's 14-ish times Jupiter's size, and it's in orbit around a white dwarf, which is very, very cool and interesting because the size and the placement of this planet around the white dwarf suggests that this was a planet that was there before that star became a white dwarf, which is something we've never seen before. Now, the exoplanet aficionados in the crowd might know that we've detected planets around things like pulsars and other types of stellar remnants, but we generally think that those planets were formed after the stellar remnant got there. So maybe it was just a giant debris field that after the star exploded that coalesced into planets later. This planet, we think, formed like when the star originally formed, when it was a hydrogen-burning star like the sun, or a little bit bigger, and then the star became a white dwarf. There was a explosion, planetary nebula thing, but this planet survived. And that's very exciting.
So is that is this like the future of Jupiter around the sun as a white dwarf?
Probably not.
Too far.
It's not exciting for that reason. Based on the size of this planet and its current orbit around the white dwarf, the astronomers think that the planet started about 50 times further away than its current orbit. So pretty far away. And this is a pretty massive planet compared to Jupiter.
Right.
So we don't generally think that Jupiter is going to survive and become something like this planet, which is in a very close orbit to its star. It sort of like was pushed inwards from the transition from star to white dwarf. But it is something that we've suspected could happen, that some, more massive planets could survive a star becoming a white dwarf, but it's not something that we've ever seen before.
Is this a field like people just haven't
Moya
been?
said,
Yeah, is this a field that people just haven't been looking at?
It shows us, the types of things that are possible and the different types of physics that could happen, and trying to fill in those gaps.
You would think that. Is a white dwarf easier or more difficult to find planets around? I've got 2 exoplanet hunters here in the show today. So, are they? They're very bright and small.
For a while.
So are they easy to see? But I guess lining up a planet to transit nicely in front of a white dwarf would be rough, right?
Yeah, it's not super easy to find a planet around a white dwarf. Possibly because there aren't many planets there, but there's also the issue of, like you said, the planets, the white dwarfs are pretty small. Even though they're bright, they have a very different spectrum than a star. They're bright in different areas than hydrogen-burning stars are, and they're very complicated objects for how small they are. So it's more technically difficult to do. And we're currently unsure whether the reason we haven't found them is because they don't exist, these planets around white dwarfs in these particular orbits, or just that we don't know enough yet to find them.
Super
also,
cool,
the
though.
transits would look weird, or they can look weird if you have a planet that's like almost as big as the white dwarf or maybe bigger.
Yeah. This planet is like 7 times bigger than its white dwarf.
Yeah, so if you have a planet that's bigger, then you end up with a V-shaped light curve instead of a trapezoid, and analyzing that is just like
almost cover it entirely.
Does it feel more like a variable star? I'm just wondering, are there other objects would have that kind of V-shaped light curve?
Like a eclipsing variable.
Eclipsing binaries.
Yeah, that's what I was thinking. Yeah, so it'd be tough to spot
some kinds of eclipsing
Data.
binaries.
Still, super cool.
Anyway, this is a very interesting object. It's the first of its kind that I know of, and I'm really hoping that we get to see more of them.
Yeah. Or, even just like Earth-sized worlds, wouldn't that be amazing if at some point in the future we find out there are Earth-sized worlds orbiting around a white dwarf, and they were like, okay, so we don't have to
It's been there the whole time.
We don't have to worry about the death of the sun. We can make it. We can survive.
We'll have a white dwarf up close here in a few billion years if we survive.
Yeah, exactly. And so now maybe we'll make it, and then we'll just go into orbit around the white dwarf, until as it cools
Spoiler
down.
alert, we're not going to make it.
They have extremely
fine. All right.
White
Sorry.
dwarfs don't white dwarfs exist for like trillions of years? Like they haven't
do.
burned
White
out
dwarfs are the other name for white dwarfs is, stellar embers, because they basically, unless, they get an infusion of more material, once it's a white dwarf, it basically just slowly cools down and becomes cooler and cooler and dimmer until it basically fades
that
to a little.
That always kind of blows my mind. The universe isn't old enough for any white dwarfs to burn out yet.
Yeah, to have matched the background temperature of the universe.
Yeah.
Yeah, really neat. It does take like a whatever, tens of billions, hundreds of billions, anyway.
Yeah.
Okay, well, Dave, you're on our screen. Why don't you tell us what you're working on and how people can find out more?
I'm still working on, I'm still at Astro Guys. I actually pulled the plug on the blog, but I'm still doing tweeting at Astro Guys with a Z. Still writing for Universe Today, Sky and Telescope. I have a few new gigs this summer, actually. I'm working with Stella Kafka at the American Association of Variable Star Observers for a series of articles on variable stars. That should be out in a few months. And I'm also working Mike Simmons, who has a new website. It's Astronomy Gear Today. We're doing some telescope reviews and gear reviews, and I'm kind of fielding around so that's another gig that's out there too. So it's weird. It seems like being locked down at home, I'm actually getting more content work done because there's nothing else to do. So.
Yeah. Kimberly.
So I am still working at American Geophysical Union, writing for EOS Magazine, which is eos.org. So definitely check out all my stuff there. I spent most of this summer writing and learning about environmental justice. And now I am switching gears back into space things. If you saw that really, really cool image of Enceladus, which if you haven't, you should. I'm gonna be writing about that.
The one with the fresh
giant,
snow. Yeah.
claws
Okay. Yeah.
Yes. Definitely check that out. And some more stuff that'll be coming out on eos.org.
Fantastic. Moya.
Hello, you can follow me on Twitter and Instagram at GoAstroMo to stay up to date. And I host a podcast called Exolore, EXOLORE. I'm coming up with a really exciting episode tomorrow, actually, that's about the new discovery on Venus. It's my first episode about an actual planet, and I had a panel of expert guests help me imagine what that life that might exist might look like.
That sounds really cool. When's that coming out? Tomorrow? Excellent.
5:30 Eastern time.
Cool. Oh, I'm looking forward to that. That sounds great. Well, so instead of shamelessly self-promoting something that I am working on, I want to, we just got the news that Emily Lakdawalla from the Planetary Society is retiring from the Planetary Society to work on books and raise children and work on a bunch of her own writing projects. And I just want to give a shout out to Emily Lakdawalla as someone who started her space journalism career around the same time that I did and was a gigantic inspiration to me and a lot of people. I honestly don't know of very many people who made that big of an impact on just space journalism and reporting. She raised the game. She dug for sources deeper than we even knew a person could do that. She had her finger right on the pulse of everything that was going on in space exploration. So really, Emily, congratulations on everything you did. And I hope you really enjoy writing and whatever happens next. So thank you for everything you did. All right, I can put everybody back on the screen so they can all say goodbye. And then we will shift over and I will do the interview. So thank you to all of our everyone watching. Thanks to my co-hosts. Thanks to all of the moderators and producers behind the scenes helping us make this thing go. And we will see all of you next week. Now, don't leave because I'm going to do the interview that I had with Terry Virts, which is awesome. You'll really enjoy it. But I will let the co-hosts enjoy the rest of their evening. Thanks, guys.
Thanks. Bye.
All right, let me get the interview queued up. There's me. And here we go. Oh, wait. How do I make this work? Full screen. That'll have to do. Okay. Here we go. I'm pleased to be joined by astronaut Terry Virts. Terry, welcome back to the Weekly Space Hangout.
Great to be here.
Well, you have written another book. You're a very busy guy during the quarantine. What's the book this time?
How to Astronaut, an insider's guide to leaving planet Earth. So my first book, View from Above, was a National Geographic book. It was a photography book with some stories of what it's like to be in space. This one is a collection of 51 short essays. It's supposed to be fun. The goal of the book was to get you to laugh and say, wow. So that's the goal throughout the book.
I really enjoyed it.
Good.
It was just, it was definitely not you could sort of pick it up bit by bit and just cover one topic at a time or a couple of topics at a time. And each one sort of nicely nestles into sort of a piece of fascination that we all have with astronauts and what they go through, from training to spacewalking to obviously going to the bathroom, and even some more conceptual topics like where humanity is going to go into the future. But each one, because of your personal experience, I found it just went into a level of depth that sort of scratch the itch to know further. And so I wanted to just go deeper onto some of the topics that you talked about in the book and sort of get a better sense. So one that I'm really fascinated by is the experience of returning to Earth in a Soyuz capsule. And this was quite dramatically sort of covered again with the astronauts who returned back to Earth on the Crew Dragon just a couple of days ago when we're recording this interview. You've experienced the Soyuz. Have you talked to the astronauts about what it's like to go through Crew Dragon yet?
I haven't spoken to them directly, but I have read some of their observations, and it sounds pretty similar. A capsule is very different than the space shuttle. The space shuttle is this nice, gentle, you do some banking, maybe 1.5 Gs. It's not, and then you land on a runway. It's kind of the Air Force way to land. Whereas the capsule is more of the Navy way. It's just when the parachutes are coming out, you're spinning and turning. It was like Mr. Toad's Wild Ride. And then the landing is more like driving into a telephone pole in your neighborhood. It's a bam, it's a crash. I got bruises. But it works, knock on wood. These capsules have been pretty reliable. So definitely a different experience, but they both get you back to Earth. One more elegantly than the other.
Right. So the Soyuz landing is really just to prevent you from dying.
It's the death avoidance maneuver. Yeah. That's what we should call it. Instead of a debris avoidance maneuver, it's a death avoidance maneuver. The Russians had put some little rockets that fire just before you touch down, and they call them soft landing rockets, myakaya pasadka. And I explained to them that they should call it less of a crash landing rocket rather than soft landing rocket.
And do you think that is going to be the fundamental experience for people who are returning to space in these capsules for a while?
I don't think there's going to be a human space shuttle landing on a runway for a while. Now Sierra Nevada has that. Actually, they have a lifting body land on a runway vehicle that's won a contract to bring cargo. So that could be modified for people relatively easily, but that's years away, if ever. So yeah, for the near future, you're going to be crash landing. And the Soyuz lands on land. The Boeing capsule lands on land. But the SpaceX capsule can't because it brings a bunch of highly explosive rocket fuel. In fact, they had a problem with that. I don't know if when they got on the boat, there were these rocket fumes leaking, and that's deadly.
Yeah.
And if you shake it too much, it explodes. That's what happened when they did their abort motor test.
That's right. Yeah.
Last year, a couple of years ago, it turned it into a cloud of confetti. So they can't land on land. They have to land in the water, which the landing so that couple milliseconds is better. And then the next hour or hours until the boat gets to you is going to be, I think, pretty miserable as you're out there rocking. I mean, it's bad enough being on solid ground, but the SpaceX guys are going to be bobbing in the water. So that's going to be exciting for them.
Yeah. Yeah. I guess until we see Starship make a landing, a propelled landing, but that's, we're still a couple of years away from that.
Yes. That'll be nice.
Yeah, that'll be good. That sounds like a nice compromise. Although I still think that nice airplane landing on the space shuttle is probably the smoothest landing experience humans are ever going to have in returning from space.
Absolutely. I'm a pilot, and I started out as a glider pilot, and that was the world's best glider was the space shuttle. So I'm kind of partial to that.
Yeah. All right. So next topic. During one of your spacewalks, you talked about how you felt the heat when you were outside the space station, and you experienced this moment where you're getting a reflected heat from the space station and the infrared temperature within your spacesuit.
Yes.
And I think that when in reading that passage, it kind of, it showed me that experience of being out in space and spacewalking, although we sort of imagine that you're in this spacesuit and you're sort of like wearing a balloon and then you're out in space and it's hard and you're weightless, we can sort of grok that. But it feels like there are temperatures, there's like other senses that you have that are triggered that maybe people wouldn't be so familiar with. So can you talk a little bit about what that experience was like and how maybe that would change our expectations of what it would like to be out in space?
The physical sensations. So I was lucky enough to do 3 spacewalks. And as part of the preparation, you get this briefing from the engineers when they think you're going to get hot in this one particular time during one of the spacewalks. And for me, it was one time I was going to feel hot and one time they thought I was going to feel cold. And sure enough, at those exact moments between those 3 spacewalks, on one of them I felt hot and on the other one I felt cold. And the heat was on the front of the space station. There's this thing called PMA-2. It's where the space shuttle used to dock. It's where SpaceX and Boeing are docking with humans. And it's all black out there. And I've had it described as like a heat boundary layer, which is an aviation air term. So that doesn't really make sense, but it sort of makes sense. Anyway, I was sitting there, the sun was up, and I was just surrounded by all this black. And I felt this, I can feel it right now in my brain. It was like pins and needles. And somehow intuitively, I knew it was heat, but it wasn't like a heat on Earth, because on Earth, the air's hot. I'm in Texas. I walk outside, it's 90 degrees. It's hot. You go in a warm bath, it's hot. In space, there's no fluid, so there's no heat transfer. The only heat is infrared energy. So it was like this infrared energy heat that just felt different than what I did. Maybe it's if you stand up against an oven and you feel that infrared energy. So it was a really interesting sensation. On the other hand, the other time, I was in the similar location in the front of the station, and the sun was down, and all of a sudden I got really cold. And I thought, hey man, these guys are 2 for 2. They called the heat and they called the cold. And on their gloves, there's this big string and you can grab it and pull it. It's pretty high tech. And that turns the battery on to warm up your fingers. It's just a coil of wire around your fingers. It's a heater. Except to grab your glove is a little bit of a pain, and it requires, you got to squeeze, and it's physical work, and I didn't feel like doing it, and I could see the sun was about to rise. So a few seconds later, the sun popped up and I was instantly not cold anymore. I mean, the sun instantaneously cured my cold. So both of those feelings of heat and cold were something inside the space station. You never feel anything like that, but outside it's like, I felt this extreme swing.
I know. I mean, it's funny because I think we try to think in analogies. I mean, and the closest analogies I have to that is times when I'm like hiking, when I'm up in the mountains and it's very cold, but it's still the middle of summer. And so you're at a high altitude, and yet, but the sun is very high on the horizon when it does come up. And so when that sun comes up, within a couple of minutes, you're warm again when you were just freezing cold just minutes ago. Yeah. And so, but again, it's funny. I mean, they say we have, we don't actually have 5 senses. We have a ton of senses, a lot of internal sensitivities. And I'm sure you don't realize how much they just play this background in your life until you're out in an environment that is so completely alien that now you're starting to go like, whoa, this, my inner ear feels a little funny about this, et cetera. So I found that portion, your conversations about spacewalking, absolutely fascinating. And you got this much just with 3. I can just imagine more and more of them building up.
Yeah, and it's surprising. And I thought I knew, there was a lot of things in the book. I thought I knew everything before I went into space, because I've been a space nerd since I was 5, and I've read every book. I spent 10 years in the astronaut office talking to my fellow astronauts before I flew on my first flight. And then on my very first space shuttle flight, we're launched at nighttime, we come flying into the sunrise, and there's this beautiful blue atmosphere before the sun comes up. And I had the thought, I've never seen that shade of blue before. And that's really surprised me. Like, how can I be seeing a color I've never seen before? No one's ever said this before. There was a lot of experiences throughout the book where there were things that I was thinking and feeling, and I've never heard anyone else say it like that before.
Yeah.
On my first flight, a couple days in, one of my crewmates said, "Hey, Terry, tap your feet on the floor." And I was like, "What are you talking about?" So I went down, I floated down, held myself, and I bounced my feet, and I almost shot through the roof. It was like this electric jolt. Like I just stuck my finger in a socket. And I was like, "What was that?" And he kind of laughed at me. 10 years, I had never heard anyone talk about this. I got back and I was talking to one of the doctors, and they said, "Oh yeah, some guys report it." I'm like, why didn't I hear about this? Apparently your nerves and your muscle, you grow in space, right? Because there's no gravity. So there is gravity, whatever. You're not getting pushed down.
Yeah.
So your muscles and your nerves stretch. Sometimes they stretch together and sometimes they stretch differently. And when they stretch differently, you get this shooting electric sensation. I had it throughout my first flight. I had it on my second flight. I thought I had torn muscles. It was so painful, but it wasn't an injury. It was just this apparently nerve muscle interaction. And the doctor said, "Oh yeah, and one of our buddies, his leg went numb and he's never recovered it." And I'm like, okay, I never heard of that. But yeah. So spaceflight is full of surprises. 99% of the time, it's mundane work, mechanical. You're plugging cables in, and then 1% of the time, it's like, it's an alien experience. You're seeing the God's view of the universe, and it's really a juxtaposition of sublime and mundane. That's
amazing. All right, so there's a whole section on food, of course, and drink, and the food part. Food's messy, etc. But the part that blew my mind, which I think has ruined spaceflight entirely for me, is that there's no carbonation in space.
It's good to be on Earth.
You can't drink a beer. All beer will be flat. You could
drink a flat beer. Yeah,
a flat beer. You could drink a flat soda.
If you could, but like this, I got a Coke right now, right? And it would just be shooting little, Coke asteroids would be flying through the station, so it would be messy.
And so you've got to drink it all flat. So everything's got to be flat.
To be honest, there's a way. Look, we landed on the moon. We could figure out how to fly Coke.
Figure this out.
It just hasn't been done. So that's a challenge, I think, for the young entrepreneurs out there. They can figure out a way to launch carbonated beverages. The problem is we launch everything as powder. And so you would need to be adding carbonated water. You can't have powdered carbonation, I don't think.
Well, and also I know that burping is impossible. So you don't want to be ingesting carbonated beverage.
Yeah. Look, not having it works well. So that is a very sad fact. And I'm a big fan. So it was kind of rough for me. And I think you probably read this in the chapter. So I thought, you know what, I'll bring tea. Tea will be my caffeine. Since I won't have Coke, or Diet Coke, I'll have tea. And oh my God, the first day or two, the Diet Coke or the tea was wonderful. And then the next 197 days, I was like, why did I get so much tea? I had bags and bags and bags and bags and bags of tea.
Yeah.
And so that really got old. So I ended up drinking like sports drinks, which I really don't on Earth very much. And that was like my thing because it was something different.
Yeah, that's like bordering on a trope there, an astronaut drinking some kind of sports drink. But again, I think like I have rough analogies. Like whenever I travel, like I drink coffee all the time, but whenever I travel, I pretty much go off coffee. It's not worth it to me for the ritual to go and try to find coffee and, like, yeah, if someone puts a coffee in front of me, I'll drink it. But apart from that, I'm not interested in trying to hunt and seek it down. But beer, man, I can't even imagine.
No beer.
Yeah. You are a photographer, and we've talked about this a bit in the past, just about how wonderful it is to have a really nice camera on board the International Space Station. And anyone who is a photographer is really familiar with just how the Earth changes from the ground as you're, especially during, say, the golden hour and times like that, when you get the nice long shadows. What's that experience like from space?
So I've got some great pictures of that, the dawn and dusk. The most amazing part of that, you see these thunderstorms. I've got photography was my thing. Obviously, I've got these giant pictures that I took in space. Can I move my?
Yeah, you know what? We'll have to use our imagination, we'll put some links to some of your stuff in the show notes, because there's lots of your pictures.
I've got
on
a
the
picture
web.
right here of thunderstorms, and the shadows just go on for hundreds of miles. And this one is just beautiful. It just goes right back. The moon is on the horizon, and all these shadows are kind of going back. It's one of those perspective things you do in fourth grade art class. And you can see those on Earth sometimes. Every once in a while, I'm in Texas, and you'll look up at night. There's like this blue and orange sunset, and there'll be these dark streaks, just straight lines across the sky. And those are called crepuscular rays. And whenever I see those, I'll get on my weather map, and I'll look 100 miles off to the east or 100 miles off to the west and find a thunderstorm. And it's the shadow from that thunderstorm that's making it, across the Earth. And the Atlantic Ocean and Pacific Ocean were the best. You'll see these sunrise, thunderstorm, and these long black lines. They're just spectacular. I'll have to give you this one picture. You can.
Yeah, that sounds great.
Yeah.
We'll use it for the thumbnail for YouTube. That sounds great. Did you get a chance to turn the camera out into space? How does astrophotography work from the space station?
That was one of the coolest things. My picture right up there is a picture of the moon coming down through the atmosphere. The Earth is endlessly beautiful and fascinating and amazing. It's a beautiful. My name of the IMAX movie I made is Beautiful Planet. It's mostly beautiful. There is some environmental problems. But if you turn all the lights off, you let your eyes adjust, and you look out, there are so many stars. And my favorite thing are these galaxy time lapses where you just see the galaxy going behind the planet. And there's so many stars you can't count them. On Earth, I grew up with a telescope. I know the basic constellations. I know that Jupiter and Saturn are right over there in the evening sky now. I know my basic way around. In space, I never recognized any stars. You couldn't find Orion. You couldn't find the Big Dipper. There's just too many of them. There's billions of them. It's just swamp.
Right.
I could see all the planets. And actually, the most, you could see Jupiter and Saturn by color. And Jupiter's super bright. You could see Venus because it's so bright, and it's yellow, white. Mars is red. You can see all the planets by colors, and so I tracked them. The most interesting astronomical thing that I saw, there's a lot, was seeing Mercury. I think very few people on Earth ever see Mercury.
I can never see it. I have a bad horizon in both directions. Yeah.
So most people have trees or buildings, or they're not really paying attention. You have to look right after sunset, right before sunrise. And I saw Mercury a lot. There's no trees, no buildings.
Yeah.
And at that time of day, before sunrise or sunset, right after, all the millions of stars aren't there. So the planet really stands out. So that was just a really interesting thing I never thought of, seeing Mercury. And I got some really cool pictures of Mercury and Venus there.
But it's fascinating that you can't, it's the the most perfect dark sky conditions that you could possibly hope for. And I know that experience, that as the better the skies get, it gets a little harder to find your way around because all of the familiar constellations fade away into just the brilliance of the rest of the stars.
Right.
That sounds both wonderful and kind of frustrating because you're like, I just want to see Orion's Nebula through my camera. Why can't I find it?
Well, and when you look at some of my pictures, you just see these little pink things. You see lots of nebula there. And if you took the time, you could figure it out. But when you're going 5 miles a second, the sky is moving.
Yeah.
And so, you don't know if you're in the northern hemisphere or southern hemisphere unless you're tracking yourself on the map. If you just go down, turn the lights off, and let your eyes adjust, and then look, you could be in the southern hemisphere, northern hemisphere. It could be morning or night. Like it's, right now it's summertime, so I know there's Sagittarius is right over there, right? But in space, it could be anything, and it's that was interesting. You'd think it would be the best ever conditions, like you said, but hard to find your way around at night.
Absolutely fascinating. All right, I've got one last question for you, and you brought this up in the book. Sort of the timing was really well timed, which is just any tips for people who are, you spent time in versions of isolation. Oh, sorry. Man. Okay. Sorry about that.
That's all right.
Do
it again.
Yeah. So you have it's a good time for some advice from you. And I know other astronauts have a lot of experience with just this concept of isolation, that you know what it's like to be close to by yourself for long periods of time. What tips do you have for people who are going through, what is probably a very difficult time for them?
Yeah, I kind of added that on after the book had been finished before coronavirus, and then I added that on. I'm actually doing hopefully a big video project about that. There's a couple things. During my flight, right before launch, an orbital Cygnus cargo ship blew up. Then while we were in space, a Russian Progress cargo ship blew up. Then a few months later, a SpaceX Dragon blew up. So there was 3 failures in 8 months. It was a rough time for space station logistics planners. But when the Russian Progress blew up, it's the same rocket that people fly on. And the next flight was with my replacement crew.
Yeah.
So the Russians decided to delay that while they did a safety investigation to make sure it wasn't the same problem that the crew would face. Thank God the Progress is unmanned. And we were stuck in space because they didn't want to send us back without a replacement crew. And we didn't know how long it was going to be. So it ended up being a month. But there's been a couple instances where astronauts were told, hey, you're going to have to stay there longer. And it's been, for the most part, pretty rough. Like it kind of bums you out. You're ready to come home and you're going to be stuck there for longer. But our crew, I think, handled it really well. Basically, me, Samantha, and Anton, we said, you know what? We're in space. We're going to have the rest of our lives back on Earth. Let's enjoy it. Let's take care of all the things that we want to do. Try and make the most of it. This IMAX movie, A Beautiful Planet, I got a lot of the shots for that in that bonus month. A lot of the pictures I took were in that last month. And so, it was a bummer, but we tried to make the most of it. And then we also tried to have a positive attitude in that this isn't going to be forever. Coronavirus is not going to be forever. It's rough now, man. People are dying.
I know.
It's really,
I know. Yeah.
It's not just, it's really bad.
Yeah.
People are losing their jobs, and that is like profoundly stressful. I get that, but it won't be forever. At some point we're going to come out of it, so if you can hang on, if you can try and be innovative and redefine yourself in a new career field or whatever it is, this thing will end. You just try and have to keep a positive attitude. I deal with things with humor. It's kind of how I deal with everything. I think being a fighter pilot, we have some kind of gallows humor as a fighter pilot, but I do have a lot of tips about that.
Yeah. No, I thought it was really helpful. And I've had a chance to talk to a couple of astronauts about this idea of productivity in a really harsh environment. Mm-hmm. And just how, I think how much of your day is spent while you're in space, how much of your day is spent in maintenance of your very existence. And
right.
then once you've gone through all of the parts to just keep yourself alive, then you get to do the work. and that is kind of that was very, it felt like a very similar thing to the situation that we just have to keep going and keep everything together. And as you say, you'll get out the other side of it. So I found that all very, very inspiring.
That's true.
Terry, the book again.
How to Astronaut.
Awesome. Well, thank you so much for taking the time to chat with us today. I really appreciate it. And we will, I'm sure we'll talk to you again in the future.
Yeah, let's do it again.
All right. Thanks a lot.
Thanks.